Hey, welcome back. Today we're going to talk about constructing a confidence interval for a difference in means. Now, this would be, if we have two different samples where they each have a mean, and we're trying to figure out is the difference significant, and so that's ultimately where we're going. And so, what we're going to be doing today is constructing those confidence intervals given a difference of means from different sources. Like always, a lot of these formulas are going to be found on your formula sheet for AP Statistics, and so when I'm referencing them, I'm going to highlight them here in the notes, but you can always find them on your sheet. Important part is to figure out what are we dealing with. Do we have a one sample mean? Do we have two sample? Are we finding the difference in those samples? Those kinds of things. What we're going to be doing is we're going to be looking at what's the shape of our distribution. And when we're looking at shape of distribution, what we need, as usual, is we want it to be normal. And as a reminder, that can take one of three forms, correct? Population is normal. Or it could be the case that our sample size is greater than or equal to 30, and we'd use our central limit theorem. It could also be the case that there is no strong skew or outliers. So there's no strong skew or outliers. Our center what's it going to be? Well, our center is going to be centered around our mean, which is constructed from our sample mean 1 minus our sample mean 2. Our spread, and think to yourself, what are some of those measures of spread that we've been using, right? So variability, it can be measured by standard deviation. And so if we're looking for our standard deviation, we can also call it standard error. X bar 1 minus X bar 2. Our formula for that is going to be standard deviation of sample 1 over the square root, over N1. Getting ahead of myself. And that's going to be squared plus standard deviation 2 squared over N2, accounting for the sample sizes of those two given samples. Okay. What we're going to be actually doing is going to be called a two-sample t-interval for the difference in means and we can do mu1 minus mu2. Obviously, we need to have our conditions, right? Because we're constructing a confidence interval, have to make sure we respect those conditions. And our conditions in this case are going to be normal, random, and our 10%. So those are our conditions. Our specific formula is obviously very, very important. That's what we're going to fill our information into. We need our point estimate, which is going to be the difference in our sample means. And we're going to do plus or minus our margin of error. Our margin of error is our t star times our standard error formula from right over here, right? And that is going to be our S1, N1 plus S2. All right. Now, where are we going to get this t star from? Well, t star comes from our degrees of freedom. Okay, so Degrees of freedom, we want to be conservative on that, so we're going to go conservative. And as we've been doing, that's going to be our n minus 1. Let's look at an example of what this might look like. So here's an experiment that can be conducted to model this confidence interval for the difference in two means. So Mr. Wilcox's class performed an experiment to investigate whether drinking caffeinated beverage would increase pulse rates. 20 students in the class volunteered to take part in the experiment. All the students measured their initial pulse rates in beats per minute. Mr. Wilcox randomly assigned the students into two groups of 10. There's a random piece, keep that in mind. Each student in the first group drank 12 ounces of cola with caffeine. Each student in the second group drank 12 ounces of caffeine-free cola. All students then measured their pulse rates. Again, the table displays the change in pulse rates for the students in both groups. So, caffeine, final pulse rate minus initial pulse rate. So this would represent an increase of 8, increase of 3, increase of 5, increase of 1, and then that was for the caffeine group, and for the no caffeine group, an increase of 3, a decrease of 2, etc., etc. Mean change is represented over here. So what other information do we need? If we're referencing our formula up top, it looks like we have our x bar 1, we have our x bar 2, those are our sample means. We also need the standard deviation of the first one, standard deviation of the second one. I'm gonna outline that over here for you. So S1 is equal to 2.70, and S2 is going to be equal to 2.62. Where would I get that information? Again, list one and then doing those one variable statistics. I'm going to be constructing a 95% confidence interval. And anytime you see that type of action, you know you're going to have to do your 4-step process. So here we go. Let's do our 4-step process. For our state, we are doing difference in means. So U1 minus U2 is the true mean difference. In pulse rate. And you also could say change. Because the change represents, or using the word change means, you know, you've got that one person and it changed. Difference would be, is there a difference in two groups? So change is a good word to use there. In pulse rate, we need to specifically outline exactly what we found our difference between. And it was caffeine minus no caffeine. Okay, caffeine and no caffeine. Well, actually, you know, I kind of misspoke, right? So change in pulse rate, it's not representing necessarily person to person in this one. It's amongst people, or amongst two samples of people. So our plan is to do a 2-sample T interval for means, for the difference in means of mu1 minus mu2. And we need to test our conditions. So is it random? Well, it is randomly assigned. So yes. Is it normal? And it doesn't express normality of the population. It doesn't mention that it's greater than 30, right? We don't have that. So we are actually going to have to draw some dot plots here. So for our dot plots for caffeine, let's see, we've got an 8, there's 1 there, 3. So this is 4, 0. So we got 1 at 3, 1 at 5, 1 at 1, 1 at 4. I'm going to put the 4 down below. This is an 8. Didn't do a very good job of labeling that. Sorry, guys. Starting my labels up top. 8. So let me do an adjustment here. So we had 1 at 4, 1 at 8, 1 at 0, 1 at 6, 1 at 1, another 1 at 4, another 1 at 0. Strong skew or outliers? Not for that one. But remember, we've got to check both of those because this one is the one for caffeine. Let's check the one for no caffeine. 0, 4, 8. And actually for this one, look, we got to go down below. So I'm going to go -4 here. Okay, let's look and see what we've got here for our distribution. Got a 3, got a -2, got a 4, got a -1, got a 5, another 5, got a 1, got a 2, -1, and a 4. Strong skew or outliers? Nope. No strong skew. Or outliers. So what would you need to show on the AP test? Well, if you're going to say there's no strong skew or outliers, you have to show that there's no strong skew or outliers. And I'm going to reference that over here as that's our normal condition. And 10% condition, yes, 10% condition. So we're going to assume that that works unless otherwise. So we can assume that there's a large enough population given that we only picked 10 kids here. So 3, 6, 9, wait, how many was it? Groups of 10, yeah, 10 kids. So what are we doing? We are going to do the point estimate plus or minus the margin of error. That looks like the exact formula of x bar 1 minus x bar 2. And really, guys, once we get down to this point, this is going to be plugging into our formula, right? So T star, because we're dealing with means, put in our standard deviation formula for 2 samples. And we're going to execute. Our difference in our means from up top, 2.7 minus 3.2 minus 2.0. We are going to do 1.2. Important to remember right here, caffeine minus no caffeine. So that would be 3.2 minus 2.0. So that's going to lend us with a positive here. Plus, and our T star value comes from our chart, right? So our degrees of freedom would be 9, and we're doing a 95% confidence interval. And so that's going to give us a T star value of 2.26. S1, 2.7 squared over 10, plus S2 is 2.62, 2.62 squared over 10. And then we're just plugging and chugging with our math there. We plug in our numbers and chug them. Remember, respect your order of operations inside your parentheses there. That gives us an interval of negative 1.491 all the way up to 3.891. As a reminder, you know, guys, you can pause this video, you can work on this, work this actual math problem out, and then check your answer coming back to it when I post it here. So what's the conclusion? We are 95% confident that the interval from negative 1.491 to 3.891 captures the true mean difference in heart rate, pulse rate. And we can add in caffeine, minus no caffeine. So what could we do with this information here? So do we have enough? Do we have convincing evidence? And we can talk about that. But notice what this interval captures. So is it possible that there's no difference? Well, if the interval captures 0, then it's possible that there is no difference, and it can vary from negative 1.491 all the way up to 3.891. So that's the basics of constructing a confidence interval for a difference in means. We're going to go through that in some problems here coming up when we get to class. But thanks for watching, guys, and we'll see you next time.